Hello everybody. In this video we are going to be looking at the solutions to the Physics 1 mirror practice problems. Well, let's take a look at our first problem. A candle is placed at a distance of 12 centimeters from a concave mirror with a focal length of 8 centimeters. The candle is 5 centimeters tall. We are given the object distance, which is 12 centimeters. We are given the focal length of the mirror, 8 centimeters, and we are given the object height, which is 5 centimeters. The first thing the problem wants to know is where is the image located? So we are looking for the image distance. To find the image distance, I need to use my mirror equation and the version of the mirror equation that has the focal length in it. And when I rearrange this equation to solve for the image distance, I'm going to have the image distance is equal to the inverse of the focal length minus the inverse of the object distance. I plug my known values into that equation, and when I do out the math, I should have an image distance of 24 centimeters. I know because I get a positive value for the image distance that the image is going to be real and it's going to be in front of the mirror. And I do know that is the type of image I should get for a concave mirror where the object is outside of the focal point. And because the focal length is 8 centimeters and the object distance is 12 centimeters, my object is outside of the focal point. So I know that that is the answer I should get. The second part of the problem asks, what is the height of the image? So we are looking for the image height. And I can use my magnification equation that compares the image height to the object height to the negative of the image distance versus the object distance. Solving that for the image height, I have the image height equals the negative of the object height times the image distance divided by the object distance. Plug my known values into that equation, and I'm going to have an image height of negative 10 centimeters. And that negative sign tells me that my image is going to be inverted, which again, I know I should have an inverted image for a concave mirror where the object is outside of the focal point. Problem 2. A candle is placed at a distance of 14 centimeters from a concave mirror with a focal length of 6 centimeters. The candle is 7 centimeters tall. So this one is going to be pretty much a repeat of the last problem. We are going to solve it the same way. Once again, we are given the object distance of 14 centimeters. We are given the focal length, which is 6 centimeters, and the object height, which is 7 centimeters. They first want to know where is the image located. So we are going to be looking for the image distance. We again will start with our mirror equation, solving that for the image distance and plugging my values for focal length and object distance into that equation will give me an image distance of 10.5 centimeters. The second part is asking what is the height of the image. So as with the previous problem, we are going to be looking for the image height, starting with my magnification equation, solving it for the image height. And I plug my known values for the object height, the image distance, and the object distance into that equation will give me an image height of negative 5.25 centimeters. Problem number 3. A candle is placed at a distance of 15 centimeters from a convex mirror with a focal length of 10 centimeters. The candle is 4 centimeters tall. So we are given our object distance, which is 15 centimeters, our focal length, which is negative 10 centimeters, and it is negative 10 centimeters because we are dealing with a convex mirror, and in a convex mirror the focal point is behind the mirror, which gives us a negative focal length, and our object height is 4 centimeters. So first we want to find the image distance, and we want to know if the image is real or virtual. So we're going to be finding or solving for the image distance. Once again, we are going to start with our mirror equation, solving that for the image distance as we've done in the previous problems, and we are going to substitute our values for focal length and object distance into that equation. And when we do the math out, we should have an image distance of -6 centimeters. And because my image distance is -6 centimeters, I know that it is going to be virtual because the negative value tells me that the image is behind the mirror. And that is going to give me a virtual image because the reflected rays, which are all on the front side of the mirror, do not pass through the point in space where the image appears to be. For part B, we want to find the size of the image and is the image upright or inverted. So to find the image height, I am going to use my mirror equation. Oops, let's try finding using a pen here. My mirror equation, solving that for the image height and plugging my values for the object height, the image distance, and the object distance into that will give me an image height of 1.6 centimeters. And again, because this 1.6 centimeters is positive, I know that is going to give me an upright image. Part C of problem 3 asks us to use ray tracing or draw ray diagrams to show the image formed by the mirror. So remember, there are 3 different rays that we can draw, and let me go through those with you. The first ray is the one represented in red here, and I just have the 3 different rays color-coded just to make it easy to differentiate between them. So for this first ray, which I have colored red, my incident ray, remember the incident ray is the one that goes from the source of light to the mirror. So my incident ray is parallel with the principal axis. My principal axis is down here, right? And my incident ray is parallel with that principal axis. When my incident ray is parallel with the principal axis, my reflected ray, this is my reflected ray that goes off the mirror here. My reflected ray is lined up with the focal point. Now this reflected ray can't actually go through the focal point because my focal point is behind the mirror and the light can't pass through the mirror. But if I were to draw a dotted line going behind the mirror and continuing that reflected ray behind the mirror, you can see that it would be lined up with the focal point. So that is my first ray. The incident ray is parallel with the principal axis. The reflected ray is lined up with the focal point. Right, now let's just erase that and let's take a look at our second ray. And the second one is the one that I have colored in blue here. And in my second ray, my incident ray is now lined up with the focal point. If I were to extend my incident ray beyond the mirror, you can see that it would be lined up with the focal point, and my reflected ray is now parallel with the principal axis. So if my incident ray is lined up with the focal point, the reflected ray is parallel to the principal axis. My third ray, just make some erasures here. My third ray, which I have colored in green, the incident ray is lined up with the center of curvature. If I extend this down a little bit, you can see that it goes through the center of curvature. And when my incident ray is lined up with the center of curvature, it will strike the mirror at a 90-degree angle. And according to my law of reflection, if my angle of incidence is 0 degrees, my angle of reflection is going to be 0 degrees, and the ray is going to reflect back on itself like so. So let me clean this up a little bit. Let me just draw my 3 reflected rays. So for the green ray, my reflected ray is right here. For the blue ray, my reflected ray is this. And for the red ray, this is my reflected ray. if I were to trace all three of my reflected rays behind the mirror, and remember I have to do this with the reflected rays, they all intersect at one point, and that point is here. So that is where my image appears to be. All of my reflected rays appear to emanate from that point, and it is that point where my image is. And because all of my incident rays were drawn from the tip of the candle, or if we use an arrow, but if it's from the tip of the candle, that means that all of the reflected rays are going to represent the top of that image as well. So those are the three different rays that we can draw to show where the image is supposed to be. Now, just as a note, you only need to be able to draw two of those rays to be able to see where they intersect, but it's always a good idea to draw all three as a good way to kind of double check your work.